In the last section, we discussed gases and looked at those properties. And now we're going to shift our attention to look at the properties of liquids. And they're going to be a little bit different than gases, because we know that all the atoms and molecules in a liquid are a little bit closer together than a solid. So we have to take into account these intermolecular forces, which we kind of ignored in gases. So what we can say is that chemical species will do anything they can to achieve the lowest energy or most stable state. And we saw this when we see molecules form. Molecules form from atoms because the overall molecule is more stable in energy than individual atoms together. So in the same way, when we have a liquid, the molecules floating around in that liquid can orient themselves to get the most stable state, or the lowest energy state. So the interactions between these molecules, or intermolecular forces, dictate the phases and physical properties of molecular solids, liquids, and gases. So these intermolecular forces are going to play a huge role in what we're going to look at when we're looking at properties of liquids. So let's kind of look at and consider a sample of HCl. So here we have our sample of HCl, and we're just going to take a snapshot of an HCl solution here. So we have all of these HCl molecules floating around, and we can say a couple things about them. So the first is that a chemical bond forms between hydrogen and chlorine. We know from previous chapters that this is a covalent bond, and it's an example of an intramolecular force. And this force is very strong, and it holds the molecule together. So its bond energy for a covalent bond is anywhere between 200 and 1100 kilojoules per mole. And when this bond is formed, the electrons in this covalent bond are not equally shared. So I've indicated partial positive and partial negative charges here on this HCl. And the hydrogen is indicated by a colored sphere, where the chlorine are the larger open spheres. So what happens is that we have interactions now between the partial negative charge on the chlorine and the partial positive charge on the hydrogen. So there's going to be interactions and attractive forces between each of these partial positive and partial negative charges that we have on each of these molecules. So we need to look at these different forces, which we call intermolecular forces. So intermolecular forces are the attractive forces between molecules. And these intermolecular forces are going to be proportional to the electronegativity difference between the species that are being covalently bonded together, in this case between the HCl. So these intermolecular forces are proportional to the electronegativity difference. So make sure you have a good background on your electronegativity difference. Okay? So the strength of these intermolecular forces, so the energy of these is typically anywhere from 1 to 25 kilojoules per mole. So in terms of the relative strengths, a bond is much, much stronger. That's going to hold the molecule together. But these intermolecular forces cannot be ignored, right? So in gases we completely ignored them, but when we go into a liquid, we definitely have to keep them in mind. And there are 4 main types of intermolecular forces that we're going to need to analyze, which we will cover in the next video.